this is lesson 5.4, part 2 of combinations, at least and at most. So, when we took a look at this question yesterday, we initially said that we had many different options we could use to do this. So, for example, whenever you see the word at least means a minimum. So we want a minimum of 2 girls. Well, we have 50 kids, half are males, half are females. So that means 25 are boys, 25 are girls. And we want to pick a group of 10 with a minimum of 2 girls. So this is where we have to add the multiple cases, because there's multiple different cases we have here. Now, we can take each individual case and then add the totals together. Or, the other way we looked at yesterday is do the total number and then subtract the complement. Okay? And that sometimes is easier because it's less work. So, that is what we're going to do. Now, just for giggles, we're just going to write down the number of choices. We had 9 different choices that we chose, or that we looked at yesterday. So, if we need a minimum of 2 girls, that means 2 girls, 8 boys. 3 girls, 7 boys. 4 girls, 6 boys. 5 girls, 5 boys. 6 girls, 4 boys. 7 girls, 3 boys. And the last, 8 girls, 9 girls, 10 girls, and their counterparts, 2 boys, 1 boy, no boys. So those are the different options we would have to figure out. So it would be each of these options, multiply each option, and then each option that I have in brackets, we get each of their options, answers, and then add them. But as it looks, those are 9 different things we would have to figure out. We're going to do the complement, because the complement is less than that. What we have is, if it's a minimum 2 girls, what's the complement of a minimum 2 girls? No girls or 1 girl. So that's what we're going to do for the complement. So I'm going to move all of those down here. Hang on, let's group them together and move them down. Okay, we're moving those down. And now we're going to do what we said. So we're going to do no girls and 10 boys. And then we're going to do 1 girl and 9 boys. So that becomes 25, choose 0, times 25, choose 10. Now what did we say the answer of anything choosing 0 is? 1. So multiplying by 1 doesn't change the answer, but you still have to show that it's there because it adds to part of your numbers. Because what do our numbers have to add to? The N numbers have to add to 50 kids, and the R numbers have to add to 10 kids. So that's what you have to make sure you have for each situation. That's why we have to include it. Even though we know it's just multiplying by 1, we still need to include it to show the work. So we've got that, adding to 1 girl, so 25, choose 1 girl, times 25, choose 9 boys. Okay, so we're going to get each of those individual situations. And this is going to give us, so 0 girls and 10 boys. I'm going to write this one's answer just up here so you guys can see it. And that's going to give me 3,268,760. 1 girl and 9 boys is quite a bit. It gives us 51,074,000. 074,375. Now we need to add both of those totals together. So when we add both those totals together, we're going to end up with 54,343,135. So that's how many ways you can choose those groups. Now remember, that's just this. We need to take the total and subtract that. So, the total ways we can choose them, well, that's 50 people choosing 10 kids. So that's our total number of ways, 50 people choosing 10 kids. So 50 choose 10 is huge. It's a billion. So I'm going to write it in green so you can see it. So in green right here, we have, that's this guy right there, 10,217,935,040. That's how much it is total. That's how many ways we could choose 10 kids, period, if it wasn't specific. Then it got specific on us and gave us some guidelines. Minimum 2 girls. Well, this is with 0 girls or 1 girl. So now what we're going to do is we're going to take this green number, the total choices, and subtract 1 girl or no girls. So we're going to take the green one and subtract the red one. And that's going to give us a final total when we subtract them of 10,217,935,040. Oh, sorry, the green number I gave you was the answer. The green number up here should be different. I apologize. I have to write the green number differently. Green number is bigger than that. The green number is 10,278,170. So it's that one, subtract the red one, gives you the blue one. By accident, I gave you the wrong number there. So, it's a heck of a lot, subtract a heck of a lot, gives you a heck of a lot. That's what it ended up being. So, if we were to use every single one of these, look at how much time that would have taken us to find all 9 of those and add them all up. If we found all 9 of those individually and added them up, we would get our answer in blue here. Okay? And if you want to check your work, you can do that on your own. That will take a while. Now it says, how many different ways could you pick a group of 10 students with at most 8 boys? Well, that means maximum 8 boys. What does the maximum 8 boys mean? That means you can't have 9 boys and you can't have 10 boys. Well, look what we have here. 9 boys and 10 boys. So, is it going to change? No, the answer is going to be identical for both of them. Okay? Because they're just asking the question in a different way. Okay? They're just asking the question in a different way. Okay? Because here they're saying, how many ways can you pick 10 students with at most 8 boys? Yep.
You said 25, choose 0 or whatever. Is there any other symbol you can use besides the C for pictures? Anything else?
No, because in the calculator we have an NPR and an NCR. So that's why we use choose and pick. Just because in the calculator it's a C and a P. Okay? For combination and permutation. Okay? That's why. Okay, I'm going to erase all these red ones for us. Alrighty. So, this question here, B at most, it just wants that one. Okay, it just wants your red answer. That's all it wants. Because it's saying with 10 boys or 9 boys. Okay, so it's going to be the exact same answer. They just ask the question in a different way. Alright, let's take a look at number 2. Again, committees. Committee starts with the letter C. Committees are 99% of the time combinations. Okay, unless they give you a ranking order. So, we're talking about a committee next. We have a committee of 5 people. Needs to be formed from 4 men and 7 women. You need at least 3 women. That means a minimum of 3 women on the committee. So that means you've got different choices. So, we could have 3 women on the committee, or 4 women on the committee, or 5 women on the committee, because it's a 5-person committee. So, we need to figure out each one of those situations and then add them all together. Okay? So, I'm just going to do the work below so I have more room. So, with 3 women, that means there's going to be 2 men. 4 women means there's 1 man, and 5 women means there's 0 men. Okay? So remember, we have to multiply the men by the women. So, 3 women. So we have 7, choose 3, times 4, choose 2. 7, choose 3, times 4, choose 2. And that's going to give us 210, I believe. Check your work, make sure I'm right. I think that one's 210. Please check your work. Somebody make sure I'm right. For women, the only way this is going to change is I'm now changing my 7, choose 4 now, instead of 7, choose 3, and it's going to times by 4, choose 1. And that's going to give us an answer of 140. Checking my work, is it right so far? Okay. Now, 5 women. 7, choose 5 women, times 4, choose 0 men. Okay, remember, anything choose 0 is 1. So, that is going to give us a total of 21, I believe. Please check. And now we have to add all 3 totals. So now you're going to add all 3 of them. So we're going to get 210 plus 140 plus 21. And that's with at least, so minimum, 3 women. And that's going to give us 371. Okay? Any questions so far? Pretty good? Okay, now we're going to move on to B. B says at most 3 women. That means maximum 3 women. So you can't have more than 3. So that's going to be set up a little differently. I'm just going to draw a line under these guys and move up. Okay. So at most 3 women, so that means maximum 3. So 7, choose 3 women. 4, choose 2 men. That's going to give us the same answer here, 210. Plus, this time now, 7, choose 2 women, times 4, choose 3 men. And that's going to give us 84. Yes, I certainly can. And the last one, 7, choose 1 woman, times 4, choose 4 men. So I've got women, men, women, men, women, men. That's what's going on there. And that's going to give us a total of 7. We're going to add up all of those. When we add up all of those, we're going to get 301. Okay, I'll give you a moment to write that down. Here we go. Okay, continuing on. Now we've got a deck of cards. So, the standard deck of cards, how many 5-card deck, or how many 5-card hands could we make out of our deck of cards of 52? Well, we would have N being 52 cards, and R would be 5. So we've got 52, choose 5 cards. And that's all we have. Now, it is a big number. It's in the millions. 2,598,960. So that's how many 5-card hands you can make just in general. So if we were doing a probability question, and we were talking about 5-card poker hands, that would be your total. That would be the bottom number. Okay? 5 cards out of 52. Okay? How many hands could you make with at least 1 diamond? That means a minimum of 1 diamond. Okay, that means one of the cards out of the 5, if not all of them, have to be diamonds. Well, you've got to do every situation. So, we've got to do 0 diamonds plus 5 other cards. That's called the complement. I'm going to choose to find the complement and subtract it from the total that I found in A. Why would I choose to find the complement? It's the shortest way to answer the question. If I want to give myself 20 more minutes of work, I would do it the long way. I would find it with 1 diamond and 4 other cards, 2 diamonds, 3 other cards, 3 diamonds, 2 other cards, 4 diamonds, 1 other card, all diamonds, 0 other cards. So you could do every one of those situations, or just the complement and subtract from the total. That's much less work. Okay? Yes?
So the other way is possible.
Oh, absolutely. The other way is possible, and you'll get the exact same answer. Yeah, no problem. Okay, so 0 diamonds. If I have 0 diamonds, that's 13 choosing 0. Because there's 13 diamonds in the deck. Now, if I take out 13 of the diamonds, how many cards are left? 39. So I need 39, choose 5 cards. Well, that's going to give me 1 times, look at how cool this number is. It's one of my favorite numbers. It's a really cool number. No! That's on the video now, you goof. Seriously. And that was Ryder Sano, by the way. Sorry. Okay. So watch how cool this number is. It's 575757. Nice. Hey, it's a palindrome. Oh no, it's not a palindrome. Pardon. Yes. 13. Okay, because we're talking about diamonds in the deck. And we're talking about 1 suit. There are 13 cards per suit. Okay? All right. Now, I need everybody's attention up here, please. This is not our answer. This is how many hands come with no diamonds. We want to know the opposite of that. So we're going to take the answer from A and subtract that answer. That will give us the total. So we have A subtract B, and we're going to get 2,023,203. A whole bunch of 2 zeros and 3s. Okay, so that is the final answer in green that you see. You take A, subtract B. Then we take a look at letter C. We want maximum 2 kings. So maximum 2 kings. So maximum 2 kings, we can think of it this way. Because that would be 2, or at most 2 kings. So maximum 2 kings. So that'd be, we could have no kings, or 1 king, or 2 kings. And that's what we're going to find. So we have 0 kings and 5 other cards. Whoops, OC is O cards, other cards. 5 OC, other cards. Now, so 0 kings. There are 4 kings in the deck. I'm choosing none of them. Timesing by. There are 48 other cards. I need to choose 5. Okay, the OC stands for other cards. I multiply that. That answer I'm just going to write below is going to give me 1,712,304. We need to add it to the next situation. 1 king and 4 other cards. OC, other cards. So 4 choose 1 times 48 choose 4. Sorry, this red number's wrong. That's the answer. Start with number 4. I wrote it number 4, and I looked at number 4's answer. Hard to do. Okay, so from the answer above, it gave us this. Okay, can everybody please check their red answer right there, please? This one right here?
Yeah.
What part of it?
Yeah.
So,
48 choose 5 first answer. And then 4 choose 0 is next.
yes. So 1 times that is this. Isn't it?
I think you had it right the first time. I got the same answers.
Did I have it right the first time?
Yeah.
Oh, I did, okay. Sorry. 171204. Okay, just making sure. All right, then the next one. This guy gives us 778 320. Make sure you get that number, please. Check my work. Okay, good to go. Now, the next situation we have to add is 2 kings and 3 other cards. So 4 choose 2 times 48 choose 3. And that guy is going to give us an answer of now that's when you multiply 4C2 times 48C3. Okay, these are the answers after these 2 sections are multiplied. Okay? And then we add these 3 answers. My answer in here is wrong because I added it to that other question. So I'm going to need it from you guys. You actually have to do the question, everybody. Okay, let's check your work. Make sure you get the right answer, guys. When you add them all together, you should get 2,594,400. Okay, that's 3C. Okay, now we need to take a look at example 4. Example 4. Now, the next one, can be done one of 2 different ways. We're good to go? May I erase this so we can start? Not quite? Okay, I'll give you a minute. So, example 4. We need to have at least 2 queens. That means minimum 2 queens in a 5-card hand. So you can have 2 queens, or 3 queens, or 4 queens. Okay? That's 3 different possibilities. Now, again, what can we do? Instead of finding 3 possibilities, find the total and minus the 2, the complement. So the complement would be 0 queens or 1 queen. So we're going to find 0 queens and 1 queen because that is much quicker. So 0 queens plus 5 other cards. 1 queen and 4 other cards. So 0 queens, 4 choose 0. 48 choose 5. Okay, there's our first ones. Then we have to add 4 choose 1 and 48 choose 4. Now, this guy, as we know from the question above, gave us 1,712,304 and 1 queen and 4 other cards gives us 778,320. We add these together, we're going to get 2,490,624. Now, that's with 0 queens and 1 queen. This is the complement of our situation that's here. So now we need to take the total, which is at the very top in 3A. That was our total. We need to now subtract this number. So our total is going to be 259,890 minus 249,624. As we can see, it's going to give us 108,336. So that's how many 5-card hands have minimum of 2 queens. Okay? Minimum 2 queens. Number 5 changes. Part A, we need to find the total number of 7-card hands you can have. So we're going to go 52, choose 7. That's how many 7-card hands are possible. Okay? And we need that first. So, how many 7-hand cards are possible? It's huge. 133,784,560. All right, now the second part of the question is saying, how many of those 7-card hands would have a maximum 6 black? Okay, maximum 6 black. What is the complement of maximum 6 or black? Having 7 black. So we're going to do the complement, being 0 red, 7 black. So B, the complement is 0 red, 7 black. So 0 red and 7 black, we're going to do 26 choosing 0, because there's 26 red, we choose none of them, times 26, choose 7. 26 black, we're choosing all 7 black. And this tells us the complement. How much is that going to give us? Multiply it out. Remember, you never have to do these ones, because anything with a 0 here gives you a 1 for an answer. So it's 1 times something. You just have to do the one question. Like that? Okay. Now, is that the answer it asked for? No. It asked for the opposite of that. So we have to do A, subtract this complement, and that will give us our actual answer they're looking for. So we're going to take this total I'm circling, and we're going to subtract the red total. Okay, that's what we're doing. We're taking A, subtract B. So 133,126,760. That's what we should end up with for that one. Okay, when we use combinations to solve pathways, we don't use the factorials. With permutations for pathways, we were able to count how many total pathways there were, meaning counting the ones around the sides, and then we divided out the factorial rows and columns. However, rows or columns. When we do it this way, what we do, we have 2 separate questions here. Okay, so everyone look, we have 2 separate questions. What we're going to do is we're going to take a look and see, do we get the same answer if you use a combination? And the answer is yes. Now, what are you actually going to do to figure these out? What you actually have to do is you've got to count the total number going all the way around left and on the top. So on the first one, I've got 4 on top, 4 on the left. Okay? That becomes your n number. So n equals 8 in this situation. Okay? Then all you do is the R number is either going to be the number of rows or columns. One or the other. You will get the same answer. We're going to discuss why you get the same answer. So this one has 4 across and 4 down. So this one's going to be 8C4. So everybody type in 8C4, 8 choose 4, and make sure you get 70 as an answer. Okay, it should give you 70. Did everybody get that? Okay, the next one. When we count, how many does it have going across and down? What is our total number? What would our N be for the first one? 6. Good. What would R be then? We have 2 choices for R. What are our choices for R? Rows going across, how many do we have? 2. How many columns going down? 4. So we have 2 choices. We could use 2 or 4. So 2 or 4. Now, I want you to type in 6C2 and 6C4 and see what you get for answers. 6C2 and 6C4. Please type both in separately and see what you get for an answer. Okay, so 6C2 and 6C4. Please type these in to see what you get for answers. Right here.
Why is that?
Everybody should get the same answer. So, the reason you get the same answer, and this will always work for combinations, and it never ever works for permutations, okay? It only works for a combination. Whenever the the R numbers add to equal the N number, they will always give you the same answer. So the 2 and the 4 add to 6. That's why they have the same answer. Let's investigate another couple examples like that. So if I've got 7C3, what would be equivalent to 7C3? What would go in the box? 4. Good. All you literally do is take those guys and subtract them. Let's go 7 subtract 3. All you literally do. Can you guys stop pissing around? Seriously. If I've got 15C11, what is equivalent to 15C11? 4. Subtract 15 and 11. It'll always work for combinations. It never, ever works for permutations. Okay? Always for combinations. Okay, so when we consider having circles with, or any type of polygon with points or vertices on the edges. So dealing with circles, if we want to form a triangle, how many points does it take to create a triangle? 3. So our R is going to be 3 because we want to form a triangle. The N number is the number of circles, or sorry, the number of points on the circle. So how many points do we see on the circle? 5 of them. So N would be 5. So all we've got to do in this case is 5 choose 3. And that's how many triangles could be formed in that circle now. So 5 choose 3 is going to give us a total of 10. Now, what's the difference between forming a triangle versus forming a line? Triangle needs how many points? 3. How many does a line need? 2. Good. So that's how the next question is going to change for us. So the R number now changes to a 2 because we're talking about a line. So the N number is still 5, but your R is 2. So it's going to be 5 choose 2. Now what do we know about the R numbers that add to the N? They give you the same answer. So 2 and 3 both add to 5. Should I get the same answer for both of these? Yes, I should. Okay? Let's move on to the polygon on the next page. Okay, now you got a pentagon. Now we're talking about the diagonal vertice lines. So, how many lines, and we're talking about connecting the points on a pentagon. So that means the edge vertice points. Now, n is going to be 5 because we have 5 sides or 5 edge points. The R number, we're drawing lines. So what would R be then? 2, good. So it's going to be 5, choose 2. And what do we get for 5, choose 2? 10, good. Now, the part 2 of this question says, how many of the lines are diagonals of the pentagon? Now, if we want to find the diagonals of the pentagon, we have to take our answer and subtract the number of sides. Okay? So what it's trying to do is it's trying to say, well, how many diagonal lines, so watch carefully, if I just start from the top point, I can draw 1, 2. Diagonal lines that are inside the object that would not be considered a side edge. So I can't consider this one because it's a side edge. I can't consider this one because it's a side edge. So from this vertice, I would have 2 lines. Does that make sense? So from every vertice, you're going to get 2 lines. There's 5 vertices, 2 lines each. What's 5 times 2? 10. That's why you get 10. But down here, we're going to get 10 of them, but we got to consider we have to subtract the diagonals on the outside because we're going to be repeating some of the diagonal lines. So n is still 5, r is still 2, but in this case, it's going to look like this. It's going to be NCR minus n. We have to subtract the side lengths. Okay? And it's because we want diagonals inside the pentagon, not the ones that are the edges that create the pentagon. So it's going to be 10 minus 5 is 5. Okay? So that's how we get to that question. Yeah. All right. Last couple questions, and then it's practice time. Now the practice questions on page 7, 8, and 9. I would like those done for tomorrow. We're going to go through those first thing tomorrow. Okay, on page 7, 8, and 9. If you look at page 6, I also want you to take a look at find the error question. Okay, I want you to look at find the error question. Okay, one last example. I know. Actually, you know what? We're going to start here tomorrow. How about that? Okay. Because, yes, we're going to stop with combinations, and then tomorrow we're going to do the mixing of the com and perms. This concludes part 2 of combinations. No. Oh, love it.
So what are your little snacks?
Okay, we're talking about mixing up permutations and combinations. So how do we know if something is a permutation or a combination? Again, it's going to depend on different arrangements. Now, when they give us keywords like the word arrangement, we know specifically we're going to be using a permutation. So this one here tells us permutation. So we need to count the number of letters in triagonal. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters. Now it says we only want 2 vowels and 3 consonants to be used. Now, what are the number of vowels? Well, there's 3 vowels in the word, and the number of consonants in the word, there are 5 consonants. So these become our R values, what we need to choose, or pick, I should say, and these become our N values. So now we're going to have 3 picking 2 vowels for our vowels, multiplying by 5 picking 3 consonants. Now we multiply each of our totals. We're going to get 6 times 60 to give us 360 choices. Now we're going to do a committee selecting 7 men from 7 men and 10 women. Now, because they told us president, vice president, treasurer, that's considered to be a ranking. When we have ranking order, that means we need a permutation. So this is also a permutation question, NPR. So if I want the women, I have 10, I need to choose 1 because we need exactly 2 men on the committee. Well, if we have 2 men on the committee, that means the other person of a 3-person committee must be a woman. Now, how do I know I need 3 people? Because they named 3 people. So president, vice president, and treasurer. The men, I have 7, and I must choose 3 of them. Sorry, I'm using choose, and it should be a pick. So these are permutations, these are picking, not choosing. So 10 pick 1, that gives you 10, and 7 pick 3, that gives you 42. You're going to multiply your totals and get 420 different selections of those 3 rankings. Now the next question you were asked to look at is finding an error question. So there are 5 popular and 6 classical music songs that they have practiced. They need to pick 3 popular and 2 classical to play. Now, it says the order of the compositions matters. We want to know the number of different arrangements of programs that they could consider. So we have 3 people, Wolfgang, Johann, and Ludwig, and they have their choices for their solutions up there. We need to decide if they're correct or if they're wrong and what is wrong about each of their choices. So, first of all, Wolfgang, he just decides the permutation because order matters. He does not consider the fact that they can be played in any order. Well, they can be played in any order. However, they're saying that they have to have 3 popular and 2 classical. Now, the order does matter. So you're going to have your populars and you're going to have your classicals. But do they have to go order it specific in terms of classical, then popular? It doesn't give us a specific choice. That's why this Wolfgang is wrong. He assumed, so this is number 1 for Wolfgang, he's number 1. He assumed that any of the 5 songs could be played. When it specifically said 3 popular and 2 classical. So he did not consider the specifics. Okay, so the specifics were not considered. All right, Johann is number 2. Ludwig is number 3. What was wrong with Johann? Well, he considered that we've got 3 popular and 2 classical. Yeah. How hot. Ooh, nasty. Okay. It's all yours. You're welcome. So, next, what we have to remember is, yes, he did permutations, and he figured the order mattered, but in this order, he's saying that the populars have to go right in order or before the classicals. And we don't know if that's the order it gave us specifically, because it didn't tell us specifically what order. But when you use the permutation in this way, this right here, this part is saying those 3 songs will be played consecutively right after each other. This also says the same thing, that the classicals will be played consecutively right after one another. And that is what's wrong with it, because it didn't consider that you can arrange them all. So, original arrangement. So what did he assume? He assumed the songs had to be played consecutively. Okay? Without arranging them. order he wrote them in is the order he assumed they should be in. Now, Ludwig, first of all, it might look wrong because he used NCR instead of NPR. But remember, sometimes we can use permutations and combinations to solve the same problem. So, is it wrong because he used NCR? Not necessarily. What he didn't consider was arranging them. So, here they're saying, choose 5 popular songs. Doesn't matter the order of them, just choose them. Here they're saying, choose 2 popular songs, doesn't matter the order, which is all fine and dandy. But then he still needs to arrange them. So he did not consider arranging them. After they were chosen. So that's what was wrong there. So which question could be actually created into a true possible solution? Well, the correct solution would be an adaptation to Ludwig. What would we have to do to Ludwig? Well, the only thing we would have to do to Ludwig is we count how many songs he needs total. He needs 5 songs. He needs to arrange all 5 songs. This is the part that Ludwig forgot. He has to multiply by arranging of 5 songs of 5 factorial. So the correct solution would be 5C3, which gives us 10, times 6, choose 2, which gives us 15, times 5 factorial, which gives us 120. And when we multiply all those together, we're going to get 18,000 different arrangements of those 5 songs. And that's how he can arrange them. The next section is the practice. I'm going to put up the answers to the practice section. First one, written in factorial notation, should be 10 factorial over 3 factorial, 7 factorial, to give us 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial. This allows us to cancel our 7 factorial, and we get 720 divided by 6, which is 120. How can we confirm that? 10 choose 3 gives us exactly 120. To win the Lotto 649, what are your chances? Well, you need to select 6 numbers. 49, choose 6. That's simple. So, 13,983,816. So to win it, you roughly have a 1 in 14 million chance of winning the Lotto 649. Number 3. The answer for number 3 is A. The answer for number 4 is 35, because you need to do Sarah plus 3 more. So it's 1C1 times 7C3. The next questions, the basketball coach. We have 10, we need to choose 5. 10 choose 5. It's going to give us 252. We have 13 choose 2, but then we have 6 times they play each other, so you have to multiply your answer by 6. And that's going to give us 468. The next one is going to be 6 choose 4, and arrange them 4 factorially. So multiply all that, because you have 4 male roles to arrange. And you're timesing it by 8 choose 3 actresses, and you have to arrange all of those roles as well. So this is your 3 actresses, female roles. And that's going to give us 120,960. The piano. So, for the piano teacher, has a group photo taken together. 3 boys, 5 girls. So, 3 boys, 5 girls. Well, the boys group, they can sit 3 factorially. The girls group, they can sit 5 factorially. The teacher, there's only one of them, so that's 1. And then all 3 groups. Well, you have to arrange 3 groups. 3 groups is 3 factorial. You're going to take each of those and multiply all their totals. So we're going to get 6, 120, and 1. We're going to multiply them all. And that's going to give us 4,320 different ways that they can be arranged in those orders. All right, the last couple questions you had to work on. Number 5, 20 choose 3, 11 40. It should say in the group, not in each group for 6A. So you got to include the older boy. 1 choose 1, that's your oldest. And he's timesing by 3 other boys. So 9 boys left to choose from. You're going to choose 3 of them. And that's going to give you 84. The eldest boy is excluded. So now you take 1 boy out. So you have 9 boys left, but you still need to choose 4 of them. And that's going to give you 126. Next question. Tom is bringing a dozen of donuts to work, so that's 12 of them. He chooses 3 to eat. So 12 choose 3. Tom has 220 different selections he can make of donuts. What is an equivalent expression to the one above? Well, what did we do? We always take and we subtract the numbers. So it would be 12 choose 9. That's how you find the other R number. 12 choose, subtract the 3. That's going to give you the exact same total. The next one, number 9, the answer is B. This can, we have a couple more. Number 10, the answer on number 10 is B. The only thing missing on B is they forgot to put English. English would be 1C1, but remember that only equals 1, and multiplying by 1 doesn't change the answer, so that's why they didn't include it in any of the questions. Number 11. For the bookshelf, 5 choose 2 English times 2 choose 2 science times 2 choose 1 math book. And you're going to times it by arranging all 5 books. So arrange them by 5 factorial. When you multiply them out, that's going to give you 10 times 1 times 2 times 120. And that's going to give you 2,400. Number 12, it is just the fundamental counting principle. You multiply the totals of each situation. So the answer is D. This concludes part 2 of combinations.